Hi everyone, this is the video for chapter 4, lesson 1. So actually this is a combination of lesson 1 and lesson 2 from chapter 4. So chapter 3 and chapter 4, we kind of skip around a little bit and don't do every single little thing in each chapter. So our previous lesson would have been chapter 3, lesson 3, and then we're going to jump to chapter 4, lesson 1 here. So hopefully you have your note page out in front of you and you can follow along with me. We're going to continue with this idea of linear equations. Previously, we talked about slope and how to calculate rate of change and how to find slope. Well, today we are going to focus on the equation in which slope is in. So before we get there, let's talk about some vocabulary. First, we have a family of functions. That is a group of functions with common characteristics. So if you think about a family, you have some common characteristics as the people you are related to. Then we have something called the parent function. So the parent function is the simplest function of groups of a group with these characteristics. So the parent function is kind of where more complicated functions can derive out of. Simplest, I think I'm spelling it wrong. Simplest. Okay. With these characteristics. So you might have a more complicated function, but it comes from somewhere. And so the original form would be the parent function. A linear parent function is this: y equals x. Or because we have the word function, it would be f of x equals x. A linear equation is an equation that models a linear function. The y-intercept is the y-intercept or the y-coordinate of a point where the graph crosses the y-axis. Or the value of y when x is 0. We did this a little bit in our previous lesson where we had a standard form and we replaced the y with 0 and then we solved for x. Then we did the opposite. Slope-intercept form is a form of a linear equation of a non-vertical line. Which is in this form. It's in the form of y equals mx plus b, where m is the slope, and hopefully this feels like a review for you, and b is the y-intercept. So let's use the slope-intercept form and identify the parts, then graph it, okay? So the only key factors that you really need to identify with your slope-intercept are the m and the b that are represented in your equation. Right here, remember we have y equals mx plus b. So m would be 2, which is the slope. However, slope is always written as a fraction. So we're going to write this as 2 over 1. It is going up 2 to the right 1. The y-intercept is b. Normally in the parent function, it is written as a plus b. So if we see a negative, then we know that the y-intercept is at -3. Let's graph this line. So we're always going to start with the y-intercept, which is at 1, 2, 3, -3 here. And the slope is going up 2 over 1. So I'm going to kind of draw a little point every time I go up 2 over 1. I'm going to just draw it. And that means if I connect all these points, which it's hard for me to do with the drawing, but I'm going to connect all these points. And I should have a straight line that goes through this graph, like that. The next question says, how does the graph of the line and the equation above change if the y-intercept is moved up 4 units? So I'm going to use a different color here. I'm going to move my y-intercept up 5 units. 1, 2, 3, 4, 5. My y-intercept is now here. My slope is not going to change. So I'm going to keep going up 2 over 1, up 2 over 1. And I'm going to connect my point. I can continue this. You're going to notice that you will have created a parallel line to the original line. However, the equation is going to look different because instead of the intercept being -3, it's going to be a +5. So now our equation is y equals 2x, 2 over 1 times x plus 2, because my y-intercept is at 2. Does that make sense? So my y-intercept is no longer in the same position it used to be. So I've got to put a new y-intercept. Problem 2, write an equation in slope-intercept form. So this says, what is the equation of a line with a 1/2 slope and a y-intercept of -5? You're going to use the original equation, y equals mx plus b, replace m with 1/2 times x, and it's a -5 intercept. So we're going to write this as -5. That is literally all you have to do. Problem 3, write an equation from a graph. So when we're looking at a picture, we've got to identify some parts. We've got to identify what your slope is and what your y-intercept is, which would be b. So let's take a look. The y-intercept, it's crossing over at +2. So I'm going to write this as 2. And the slope, I'm literally going to pick 2 points on my line that are easily identifiable. So I could pick a point here, I could pick a point here, but these are all kind of really easily identifiable points. I could pick a point here. And I'm going to just count and look at the movement, the rise over run from one point to another. So if I'm picking this point to this point, it is going down 1 and to the right 1. So as the rise over run would be a -1 over +1, because it's going to the right 1, so the right here would be positive, going down would be negative. Therefore, my slope is -1, -1 over 1. So to write this as an equation, we will write it as y equals -1x plus 2. And that's it. Coming down, we're going to talk about finding the equation when you have 2 points given to you. What equation in slope-intercept form represents the line that passes through the points 3, -2, and 1, -3? So first of all, we need to use the 2 points to find the slope. Every equation has a slope. when you have 2 points, you can always find the slope because you can just find how the movement between the two look. And so how do I find the slope? We've talked about this before. It's y2 minus y1 over x2 minus x1. And so since you have 2 points, I'm going to label this as my point 1. So it's y1, sorry, x1, y1. And this point would be x2, y2, because I'm going to look at this as kind of like my second point. Then I'm going to replace them with numbers. So I'm going to write -3 minus -2 over 1 minus 3. When I work this out, -3 minus -2 is -1. 1 minus 3 is -2. A negative over a negative is the same thing as a positive. So I can also look at this as 1 over 2. The slope is 1/2. I'm going to use the step 2 is I'm going to use the slope and the coordinate of 1 point to find b. Then I'm going to write my equation like this. I'm going to write y equals mx plus b. But instead of writing m, I'm going to replace it with the slope. So originally, I'm going to have y equals 1/2 x plus b. Now, the goal is I have to find b. So I am now going to replace y and x with the values that are found in one of my coordinates. So I might use the first one, 3, -2. Now 3 is x, so I'm going to replace x with 3. It's going to be 1/2 times 3. Then for y, it's -2, so I'm going to replace y with -2. Hopefully you're seeing where this is coming from. Then I'm going to solve for b. So now it's just a simple math equation. I'm going to bring my work over here because I'm running out of room. 1/2 of 3 is 1.5. And that's going to be plus b. Then I'm going to subtract 1.5 on both sides. And then when I work this out, this will be -3.5, or as a fraction, it's going to be -3 and 1/2. So we're going to substitute the slope and the y-intercept into the slope-intercept form. And so I'm going to replace y equals m would be 1/2 x plus -3.5. So instead of writing plus -3.5, I'm going to just write it as -3.5. Now, if you wrote 3.5 as a fraction, it would be -7/2. And so another option would be to write this as y equals 1/2 x minus 7/2. Or 3 and 1/2. Your choice. All right, going down. What is the graph of each linear function? So we're going to graph these equations with a line by determining the information that we have. So remember, the big things is looking at these things right here. The m slope is -3/1, and the y-intercept is +4. We always start with plotting the y-intercept. Then from there, we can count our slope. It's going down 3 to the right 1, down 3 to the right 1. Then I can connect my points. Ah, my board is not good. There you go, a bit of a stretch. There's your line. Over here, my slope is 1/2. My intercept is -3. So plot your intercept first. Then from there, you can count your slope. It's going up 1/2, up 1/2. We can continue that. And then we're going to connect them. And there's your line. You want to extend your line all the way through your graph. I'm having trouble because of my writing pad, kind of limited. But remember to plot the y-intercept first. And then use the slope to locate other points on the line. Okay, our final problem, modeling a function. So let's look at the situation here. A plumber charges $65, a $65 fee for a repair plus $35 per hour. So per hour means that that is probably going to be the change that's happening. And you have a baseline of $65. So normally we would might say 65 plus 35 times H, okay, equals the total cost, equals T for total, maybe. However, since this is going to be an equation we draw on a coordinate plane, we are going to kind of just transition that this 35H, $35 per hour, we're going to write 35X, and then it's with a baseline of $65. So you have to start at $65, meaning when I am drawing my line, maybe this is, let's see, my x-intercept down here, my y-intercept down here, 10, 20, 30, 40, 50, 60. So I'm counting it by tens. And this would be 70. So my y-intercept is going to be right here. I'm going to use a different color here. So here's my y-intercept. And then it goes up 35 per hour. So I'm going to count up going 35, which means 10, 20, 30. This would be 90. And then 35. So I'm going to draw a point here, and then going up 1, 2, 3, 35. And then to the right 1, because for every 1, this is 1, 2, 3, 3. And I'm going to connect my points. And so you have a line drawn. For every hour, it's going up $35, and it's starting at 65. So if I look 2 hours, it's going to cost me whatever this says over here, however much. Or yeah, that's 3 hours actually. 2 hours would be over here. That would be like $95. So there you go. That's applying that function equation to a real life situation. All right, that's all I have for today. I will see you next time.